My name's Roger Ford and I'm the product manager for all things JSON at Oracle. Today I'm going to be talking about Autonomous JSON Database, which is a document cloud service with MongoDB compatibility. This is part of Oracle's Autonomous Database offering. So Autonomous JSON Database grew out of Oracle's converged database strategy. Our aim is to provide a single database for all of your types of data. So why would you choose to use a specialist database for each type of data that you need to store when you can store all of them in a single database? That means you get all the benefits of a single vendor, single support environment, and a consistent API over all of your data. It also means you can combine all of your data and use all of these different types of data in a single application without having to export data from one system to another. Oracle Autonomous JSON Database is a fully managed cloud service. It's based on the converged Oracle database and it's aimed squarely at application developers who want a straightforward, easy way to work with JSON data without the need to worry about managing the database itself. We provide a native binary data type stored in the Oracle database, which allows for very efficient access to JSON data with all the scalability advantages provided by the Oracle database. You can interact with that JSON data through familiar NoSQL style APIs from your favorite programming languages without needing to know SQL at all. But as we'll see, it goes beyond that because you can still have SQL access for powerful analytic reporting capabilities. Autonomous JSON Database provides the same benefits that you'd expect from other NoSQL document stores like MongoDB Atlas and AWS DocumentDB. You get fully elastic storage. You can choose how much CPU and storage you want and seamlessly expand or shrink those allocations without interrupting workloads. So you only need to pay for the CPU and storage that you're actually going to need to use at any particular time. You can even select to have the system scale automatically to 3 times its initial CPU allocation to deal with workload spikes. When the workload drops, so does the CPU allocation. It's fast, it's really fast. You get latency in the single-digit milliseconds, and performance tests have shown that Autonomous JSON Database is faster than both MongoDB Atlas and AWS DocumentDB. It's highly available. You get all the benefits of Oracle's Exadata architecture, along with optional data guard to protect your data from pretty much any kind of failure. And finally, it's low priced, coming in at around 25% of the price of its sister database, Autonomous Transaction Processing. And I'll be discussing more on the differences between Autonomous JSON and Autonomous Transaction Processing in a few slides' time. Now, I said you get all the benefits of a document database, but it goes well beyond that, because here's our big advantage over other document stores. We can use both SQL and non-SQL APIs to access our data. So in the center of our picture here is the Oracle database. JSON documents are stored in a binary JSON column, with each document being stored in a row of a relational table in the database. Then we have 2 ways of creating and accessing those JSON documents. We can do it using simple NoSQL APIs on the left, or using normal SQL for power users wanting to do advanced queries, shown on the right. So let's take a look at the left-hand side first, accessing the data through NoSQL APIs. This is where we expect the bulk of our application development to happen. As said, we expect most developers to work through our NoSQL APIs. And you have a choice of 2 methods here. First, there's a long-standing SODA, or Simple Oracle Document Access, APIs, which are integrated into PL SQL, into our own development tools, and into several programming language drivers. And secondly, there's a new API for MongoDB drivers and programs. That means you can access the Oracle database from MongoDB programs like Compass and Mongo Shell, and you can connect pre-written MongoDB programs to Oracle simply by changing the connect string used to connect to the database. So more about the Oracle API for MongoDB. This provides us compatibility with version 3.6 of MongoDB, provides full CRUD capabilities, create, read, update and delete, together with the ability to do DDL to create or drop collections. It's aimed at developers who already have experience of MongoDB and may not want to learn a new API to work with Oracle. It also allows companies to consolidate their systems by migrating MongoDB data into the Oracle database. Of course, data that's created through the MongoDB API can be queried through Soda or SQL, and data created in Soda or SQL can be accessed through the MongoDB API. So you're not restricted to one or the other. You can enter your data either way and access it any way you want. In terms of packaging, it's shipped as part of ORDS, which is the Oracle REST Data Services, and it's available in Autonomous Transaction Processing and Autonomous Data Warehouse, as well as in Autonomous JSON Database. It's in limited availability now, and we're going to be moving to general availability in a few weeks' time. So if you're interested in trying this out, please do get in touch with me via the email at the end of the presentation. Limited availability customers will get direct access to the development team for enhanced support. Now let's have a look at using the MongoDB API. So I'm logged into a command shell here, and I'm going to run the Mongo shell to connect to the Autonomous database. So this is the standard Mongo tool. We haven't modified it in any way. So we call Mongo shell, and we pass it Autonomous database username and password. I'm using admin here, but you can use any user who's been granted web access privileges. And I pass in the URL for the Autonomous database, and that URL can be found in the OCI console pages. We just need to copy it from there and paste it into here. So that's connected me to the Oracle database, and Mongo Shell here really doesn't know that it's connected to Oracle at all. As far as it's concerned, it's just connected to a Mongo database version 3.6.2. So we're in the tool and we've made a new connection, and now I can create a collection within our database. So standard MongoDB command, db.createCollection and products. Then if I do a show collections, it lists all the collections in my database, which in this case is just the one I've created, products. Now let's add a couple of documents to the database. So again, we use the standard Mongo command, standard syntax, and we do insert one and provide it with a JSON document to insert into the database. We get a message back saying acknowledged true, and because we didn't specify an ID, it's allocated an object ID to our document, which is listed there. Okay, so let's do a find now. We are searching for documents that have type movie in the JSON. So this is what's known as a QBE, query by example. Rather than a complicated query syntax, I just specify a mini document in JSON, and the database returns all documents that contain the same JSON. In this case, obviously, there's just one document that matches that query. So let's look at updates. Say I wanted to set the price for all movies to 7.5. I can do it like this: db.products.update, then I provide a QBE to specify which documents I need to update, and then I do a set operation to set the price to 7.5 for all of that document. And the database has fed the results back to the Mongo shell, which is listing them here, and it's saying that it has matched one document and updated one document, modified one document. And finally, I can drop a document. As similar to the update command, I specify a QBE to tell it which documents to drop, and it will drop all of the documents that match that. So here, the actual operations are all being done on the Oracle database, but that's feeding back the results in a way that the Mongo shell would understand, and it thinks it's just connected to a Mongo database. So what have we seen here? That's the create, the insert one, that's a read, the find, the update is an update, and the delete is a delete. So there we go. That's our create, read, update and delete, or CRUD operations through the MongoDB API connected to an Oracle database. Right, so back to our architecture slide. We're now going to look at the right hand side, SQL access. This is where we get full interoperability between JSON and SQL. So we can run advanced reports on our JSON data, and also we can convert any relational data into JSON so we can work with it alongside our JSON documents. So SQL JSON is something which is provided in our core converged database. It's not limited to the Autonomous JSON service, but we do of course take maximum advantage of this within AJD. But what you can see here you can use in any Oracle database from version 12.1 onwards. Most databases force you to treat data purely as JSON or purely as relational. Some document databases are introducing rudimentary SQL support, but it's very basic compared to the power of Oracle SQL. We allow you to do relational select queries directly against JSON document data, and the output from that select will look exactly like the output from any other relational select, and it can be further manipulated in unlimited fashion through normal SQL operations. And we also give you the tools, as we'll see, to generate JSON directly from relational tables. So here's a simple example of accessing JSON data from SQL. This is what we call the simple dot notation, and this works very well if your table is flat, that is, it doesn't contain any arrays. If this is an AJD collection, the table name will be the collection name, in this case purchase order, and the column will be called JSON document. So we can simply refer to each element of the JSON as table alias dot column name dot field name. So this particular query restricts us to only those JSON documents which have a purchase order number of 1600 within the JSON itself. So it's important to understand that that purchase order number is not a relational column, it's a field within the JSON itself. So that's field access via simple dot notation. Now if our JSON contains arrays, then we can unnest those arrays using the JSON table operator. This is a table function which generates one relational row for each element of the JSON array. We can then perform a self-join from this table function and the original collection table, as we see in this example. So this is collection unnesting using the JSON table operator over an array, and in this case the array is line items within orders within a JSON document. So now we're going to look at JSON generation. We've got the standard emp table here, emp no, ename, job, etc. And we want to generate JSON documents from that. So it's really straightforward. We just use the JSON operator and tell it which columns to include in the JSON. So here we are fetching two columns, emp no and ename, from the emp table, and that is going to generate syntactically correct JSON document for each row of the table. And in each row we have, or in each document, we have a JSON key, which is the column name, a JSON value, which is the column value. So each column that we specified in the JSON operator will generate another JSON element. Now, that was simple enough, but what if we've got multiple tables? Let's look at a more complex example. We want to combine two tables. In this case, it's the classic emp and dept tables. So what we want to do is get a list of employees in each department. So we can do that using two operators, JSON array ag and JSON object ag. If we look at the object ag first, we're using that to assemble a JSON document from each employee name, and as it's array ag, it's going to create an array from each employee name. So this nested subquery is specifying the department number from the outer query dept. So you've got an inner query against ept, an out against emp, an outer query against dept, and then outside in the outer query we are using JSON object ag, and that assembles a JSON document from each array. So let's run that and see what we get. We get a single JSON document which has the department name as a key for each array, which is the employees for that particular department. So there we go, we've combined emp and dept and turned them into a single JSON document that lists the employees by department. Now finally, let's look at schema discovery. With relational data, you need to plan your schema, the layout of your data, in advance. JSON is sometimes described as schemaless, but it really isn't. It's just that the schema is derived from the data itself and can therefore evolve over time. So it's more schema later than schema first. Oracle provides a capability to sample your data and generate a data guide which tells you the layout of your JSON data along with metadata details such as the maximum value lengths in each case. You can also automatically create relational views over your JSON data, which is a powerful way to hide the details of the JSON itself and make it look like a purely relational table or view. So some might ask, if this is a converged database, why do we need a separate service for JSON? Now, that's a perfectly valid question, but the answer is that we don't need one. You can do everything that's possible in AJD in autonomous transaction processing as well. So AJD can contain relational data, but it's offered at a lower price than ATP, and therefore we limit you to 20 gigabytes of non-JSON data. You can have as much JSON data as you want, subject to the number of terabytes of storage you've allocated. So if you start with AJD and then later find you need more than 20 gigabytes of non-JSON data, there's a one-button upgrade to full ATP without any need to take the database down. For trials, you can get an always free version of either ATP or AJD, both of which are limited to 20 gigabytes of total data. That's either JSON or non-JSON data. So to summarize, AJD benefits from the full autonomous database infrastructure. There's no need for a DBA, there's no need to worry about security updates and so on. Gives you full SQL capability for advanced analytical queries. It gives you unlimited ACID transactions on your JSON data. Provides easy no-code or low-code application development through the Apex environment, and it gives you all of the advanced security Oracle has developed for its core database over the last 40 years. Now we're going to go over a quick demo of Oracle's Autonomous JSON Database. So I'm in Oracle Cloud, I've just logged on. I can go to the menu here on the left and choose Oracle Database and then Oracle JSON Database. This lists my current databases, and I can create a new Autonomous JSON Database extremely easily. So I have to give it a name, a display name, and a database name, and I've got a choice of workload types for Autonomous JSON. The workload, of course, is JSON. I'm going to choose shared infrastructure, and then I can choose my CPU and storage settings here. Then I need to set a password for the admin user and confirm that, and I need to set the IP addresses from which I can connect to the database. When I've done that, I just need to click on this Create Autonomous Database button at the bottom, and it will take around 1 minute to create and provision that database for me. But I'm going to go back and use one which already exists called Demo. So here's the information about my database, and if I click on Service Console and then Development, down here I can see the URL to attach to this database using a MongoDB program. So I will copy that, and here I can enter the Mongo shell command that will connect me to the database. There's the Mongo shell command, and I'm passing it the URL that I just took from the console and my username and password. I'm now connected, and I can create a collection. That's db.createCollection products, and I'm going to insert some documents in there. We'll insert 3 documents, first one, second one, and a third one. We'll just clear the screen, and we'll do a find to get all of the documents in our collection. So we can see that we now have 3 documents in there. Now let's do a QBE, query by example, and I'm going to find all the documents which have type movie, and there should be 2 of those. Sure enough, I get 2 hits there. And if I was to change that to book, then it would only find the one book that we entered. Now maybe this book's a little expensive, let's update the price on that. So to do that, I need to do an update operation, update 1, and I'm specifying the ID of that book, and the current price is currently $17.05. I want to set it to $12.45, and it tells me it's modified one of those. And if I search for it again, that would be that one. I searched for it by ID, and sure enough it was 1705, it's now 1245. Okay, let's go back to the cloud and our database and click on database actions. Now I need to log into here with my username admin and the password. Now in database actions, and the two things I'm interested in here are JSON and SQL. So let's go to JSON first of all. Now this shows my collections. In this case I have just that one products collection that I created in the Mongo shell. So I can see I've got all those 3 documents there, and we can see that the price was updated for our book to 12.45. I can make further changes here just by hitting that edit button and changing that to 10.45, for example. If I went back to the shell and ran that query again, we would find that sure enough it's been updated here as well. So that's JSON. If I go back to database actions, I can go to SQL, and this is the SQL view of the same data. So there's a table called products, and that stores the JSON documents for the collection of the same name. And I can see it's got various columns in the database. If I do select star from products, then we can see the ID for those products, some metadata fields, and then blob, which contains the JSON document. If I want to see the actual contents of that JSON document, then I need to use JSON serialize and then JSON document, and that will fetch back the text of that JSON document. So you can see here we have a table, it has 3 rows, and each of those rows represents a JSON document. And if I want to look into the JSON from SQL, I can do that by using the simple dot notation. So here we've got the table products, we're giving it an alias P. Our column holding the JSON is called JSON document, so we just need to refer to, for example, p.jsondocument.type. Underscore ID needs quotes around it just because it's got a special character in there, but we don't need that with the other columns. So let's run that, and we can see that now we're getting this data back out of the JSON just as though it was a relational table. So that's a completely relational view over our JSON data. And just finally, an example of JSON table to unnest the actors. So we've got this nested operator which is taking the actors array and expanding it so that each actor has a separate row from the table. So there are our movies, and we can see that we get separate lines for each actor in each movie. So there's much more that I could show you there, but that's all I've got time for now. If you're interested in using the Oracle Database API for MongoDB, please do get in touch. There's my email address. You can contact me by email, and then we can enable the Mongo API for your autonomous database, either ATP or AJD, and we can also offer you additional support directly from development, as well as the standard Oracle support for autonomous database.